Good day, SS1 students of Sleek Angels International School. How are you? I believe you're doing well. This is your teacher, Miss Constance Onwuna. Today, we'll be looking at standard separation techniques. I have been able to introduce this topic the last time I was in your class. So today, it's going to be a continuation of the topic, okay? You know, the last time I was in your class, I told you that there are so many separation techniques, and I listed them for you. We were able to look at 3 of them, and I made a promise to you that I will do a video class in order to cover up the other ones. So today we're looking at just four separation techniques, all right, and they are right on the board. We have sublimation, filtration, separating funnel, and precipitation. All right. So I'm going to take my time right now to explain all of them and give some practical demonstration on how they are being performed in the laboratory. Okay. So let's go ahead with the first one, sublimation. So what is sublimation? This is a process in which a solid, when heated, changes to a gas. When a solid is heated, it changes to a gas. Now let me remind you that there are 3 states of matter. You have the solid state, you have the liquid state, and then you have the gaseous state. Now normally in transformation, it is supposed to move from solid to liquid and then from liquid to a gas. But in sublimation, it moves from solid directly to a gas. That's just the difference between sublimation and any other process of transformation of matter. Okay, so you're having a gas changing directly to
examples of substances.
You're having a solid changing directly to a gas. That process is called ammonium chloride, camphor, air fresheners we use at home. There are substances that can sublime. Now, last year they asked them in why they gave them substances, and then they asked them to list out those ones that can sublime. Good thing, I've given you examples so that when you come across questions like that, you'll be able to know and then list out substances that can sublime. Okay, so if you look at the camphor you have at home, when you go to buy camphor and then you keep it in the house, allow it for some time. When you go back there, you might not be able to find that camphor. What happened to it? Was it eaten? No, it's sublime. Okay, now what happened? It moved from solid directly to gas. That's sublimation for you. When solid substances heated, when they are heated, and then they change from that solid state to gaseous state. So I'm going to just demonstrate how iodine sublimes. Okay, you're going to see it, and then you understand better what I had explained to you. Okay, so right now I'll just wear my hand glove because there's no way you'll be conducting practical chemistry and then you will not wear hand gloves. All right. Okay, so just quickly wear my hand glove now, and okay, beautiful. And then I also wear my nose mask because the gas that will be released is a bit toxic and choking, so I need to protect myself. All right. So what do I do now? This is a wire gauze. This is Bunsen burner, our source of heat, and then this is the tripod stand. All right, and we have crucible. This one is used for heating in laboratory. Okay, and then we have the spatula serving as our spoon. Okay, and the iodine crystals, they are here. So I'm going to just bring it out. So I take a small quantity of iodine, just small. All right, and then I'll heat it. So all we'll do now is just to observe what happens, how the iodine crystal will sublime. All right. Okay. Wow. Look closely, you will see that there are purple vapor. That's gases. Okay. You can see that the iodine itself is being converted to a gas, a purple gas. Okay, that's actually what is happening there. Iodine was solid. Now we're having purple gas. or gases coming out. So this is a typical sublimation technique. Okay, so that's it. We come close. You might know, I don't know, but this is exactly what happens. Wow, wow, this is beautiful. Wow, the colors are so beautiful. Purple color. All right. So this is sublimation happening actually. At the end, we will not have our iodine again. It will just be, as in the crucible will be empty because all the iodine must have been converted to gas or gases. All right. So wow, wow, this is beautiful. All right. So as you can see, wonderful. They are no, just put up they've all been converted to gas. All right. So that's actually the demonstration for sublimation. Wow. So right now we're going to look at the second of my separation technique, which is filtration. So what is filtration? All right. This is a method used in separating insoluble substances. Please take note of the word insoluble. So insoluble substances from a solution. That means you can have a solution and then there are insoluble substances in that solution. What does it mean to be insoluble? It means that that substance cannot dissolve in water. Okay, so now if you have a mixture like that, how do you recover that substance and have your water? You pass that solution through filtration method, and then you have your substance, and then you also have your solvent, which is the water. Okay, so I'm going to just demonstrate how filtration happens, or what happens during filtration. Now we are going to recover calcium carbonate from calcium carbonate solution. So if you're giving calcium carbonate solution, how do you recover calcium carbonate from that solution? Very simple. Now, this is our apparatus for the experiment. Now you have the retort stand, you have beaker, this is 300 ml beaker, and this is a funnel. And then, what else do you need? You need a filter paper, okay? You have a filter paper like this. All you need to do is fold that filter paper, divide it like this, and fold it in this way. So you have something like this, and then you fold it again. This is how you fold filter paper. Now at the end, you have something like a funnel. Alright? Now this is the shape you're looking for. Something like this. It's like a funnel. Okay? Now this is the shape we want. And then what do? Put it here. So the funnel. Alright? And then make a solution. Let's make a solution of calcium carbonate. Just take some sample of calcium carbonate. This is it. 1, I have 2, and then 2 reduce. Okay. Calcium carbonate. And then we make a solution of this. How do you make a solution of this? We add water, okay? Add water and then a solution will be formed. Wow. Now this is a solution of calcium carbonate. Alright? We stir. Use this to stir. Use a dropper, I'll just use it for stirring. Stir. Now this is a solution of calcium carbonate. What is in here is calcium carbonate and water. How do you recover calcium carbonate from here? All you need to do, like I told you earlier, is put this through a filtration method, and then you have your pure water and then calcium carbonate. Now, I'll just pour it here. Remember, this is your filter paper, and then you pour it here gradually. Shake very well so that that's right. Pour it. Alright. Now this process is usually very slow, so you must be patient when performing filtration. Okay, you must be patient with it. At the end, you see water, pure water, clean water coming down through the funnel. into the beaker, right? So let's just be patient to watch what happens. Okay. Okay, wow, it's already coming down. Yeah, this is exactly what I want you to observe. Clean water without calcium carbonate. Okay, I'll just add again. Okay, that's all. Clean water. We pass through the filter paper and then enters the beaker. Alright. Now, there's a point I want you to note. At the end of your filtration, the solution you have in the beaker is called the filtrate. Okay, the one that was able to pass through the filter paper and then enters the beaker is called the filtrate. Filtrate is spelled, of course, the filtrate. Okay, now at the end of this, you will see some particles of calcium carbonate that will stay at the or on the filter paper. It is called the residue. Okay, so you have the residue and then the filtrate. And sometimes in I think it was last year, okay, this year is right, they asked them to draw a filtration process and also explain the filtrates and then the residue. Okay, so the residue is the one that stays on the filter paper, the solid substance you later get, while the liquid substance that pass through the filter paper, through the funnel, and then into the beaker is the filtrate. Okay, take note of that. Alright, so this process is very slow. Because of time, we're going to move to the third method of separation. But you can see very well that we're having clean water here coming from the funnel, very clean. It wasn't, when we started, it had some particles of calcium carbonate. Alright, so I'm going to just shift it aside while that process continues and then work with the next one. Now, the next one is separating funnel. What is separating funnel? This is a method used in separating immiscible liquids. Take note of the word immiscible. They are immiscible because they do not mix together. You can just notice the difference. Okay, you see that mixture? Okay, I think the right word is heterogeneous. Remember that I told you there are two different types of mixtures. You have the homogeneous and heterogeneous. Homogeneous mixtures, you cannot detect the difference. They are uniform in appearance. But heterogeneous mixtures, they are not uniform in appearance. So if you have mixtures that are heterogeneous, example is petrol and water, or you have oil and water. How do you get petrol from water? Through separating funnel. Okay, so the apparatus used is the separating funnel. So this is it. I'm going to just demonstrate that so quickly for you so that you will see. So this is our separating funnel. It's a typical separating funnel. This is Ritostan, like I mentioned earlier. Okay, and then we are going to have a beaker here. This is 500 ml beaker, and then this is our mixture, a mixture of petrol and water. We are going to be separating it so that we get our petrol and water. I'm going to just turn this so it will be easy. Okay, so make sure that this thing is not open so it doesn't spill when you start. So we open here, alright, and then we get a funnel. I'm going to just cover my nose because petrol is a bit chunky, the smell. Alright, so I'll have this. Okay, so you have a mixture of petrol. Mixture of petrol and wow. So this is how it looks like. You have petrol and water mixed together. But you can notice the difference. The upper part is petrol, while the down is water. But we want only water. How do we get it? Remember I told you through these separation techniques. Alright? How do I do? Very simple. Very, very simple. I just left here open and then allow my water to flow. That's exactly what I will do right now. So allow the water to flow. Okay. So just raise this so it doesn't waste. Okay, allow the water to flow. You must be careful so that the petrol doesn't enter. This separation technique requires carefulness. Alright? So your hand must be here. So you don't let the petrol flow through. Okay? Alright, so that's it. The water is going now. And then we're almost there. At this point now, you start letting it go little by little. Yeah, that's it. Beautiful. Wow. Wow. Oh, wow. This is our water. This is our water. And all you have in this funnel is the petrol. Now, we can get our petrol. We use another beaker. And then we let petrol flow. Wow. Wow! You can try this at home if you want. That's if you are separating funnel. Wow. Wow, this is beautiful. This is science. Okay. So that's it. This method is so simple if you have a separating funnel. So simple. So this is our petrol and this is our water. When we started, it was mist. Now we're having just the petrol and then the water. Okay, so that is that for separating funnel. We are done with the third method of separation technique for today. So let us go into the last part, which is precipitation. Precipitation. Okay, so what is precipitation? All right, this is the process of formation of solid doing a chemical reaction. Now there are so many, there are different types of chemical reaction. Alright, well there are some reactions we will do and then you won't see any solid. There are some you just see gases and then there are some you just see liquids and all that. But there are some reactions you do in the chemistry laboratory and then you will find that you started with solutions and at the end you have the solid in that solution. Remember that a solute plus a solvent will give you solution. But now you're having two solutions that are joined together and then all of a sudden a solid is coming out of that solution. That process is precipitation. Formation of solid doing a chemical reaction. Okay, now the solid form doing that reaction is called a precipitate. A precipitate. Now we have different the solid form doing the reaction is called precipitates. Okay, precipitate is formed when two reactions happen and then there is a solid. That solid is called precipitate. Now there are different colors of precipitate. You could have a white precipitate, you could have green, yellow, blue. That's depending on the elements in that compound or solution. Alright, and they are gelatinous. They are gelatinous precipitate. You have just normal transparent precipitate. Alright, so I'm going to just demonstrate this precipitation reaction so that you understand better what I'm explaining. It will not just be talking and talking and talking. We need to see it. Okay, now an example is the reaction between calcium chloride and sodium carbonate. They are both salts. Alright, this is also a base. Right, so calcium carbonate reacts with sodium carbonate. Calcium chloride reacts with sodium carbonate. Calcium carbonate will be formed and sodium chloride. Now, if you need calcium carbonate, remember that calcium carbonate is also called limestone. Okay. Now, if you need calcium carbonate, all you need to do is to filter that thing. The calcium carbonate is the precipitate that will be formed. These two are solutions joined together, and at the end, this will have this product. Okay, so we're going to see it very simple. So I will just have calcium chloride. This is a calcium chloride, and then this is sodium carbonate. We are going to just perform the reaction so that you will see it yourself. Let's not be that I'm just talking here. Okay, so I take some amounts of calcium chloride, like let me take 3. So I have 3. Okay, beautiful. I And then add this. Just watch. All they are transparent, they are white, and this is what happens. Wow. Wow. Can you see that? Wow. Can you see? This is exactly a formation of precipitate. If you look closely, you will see some particles of solid in it. That's the precipitate I was talking about. We started with clean solutions. Look at their colors. Transparent. And at the end, we're having a white precipitate form. So we can say that this is a white precipitate form. And this white precipitate is called calcium carbonate. Now, we cannot use it like this. What if we need just calcium carbonate, or we need a sodium chloride that is there? What do we do to get the solid? Because it is an insoluble solid. The soluble solid, the soluble one is the sodium chloride, but the one that you can see very well and we say is a precipitate is insoluble. Okay, that's why we can see it. Now, how do we recover it? Just pause this video and think. I've already mentioned to you that you can recover an insoluble solid from solution using a method. What's that method? Can you remember? We just finished it now. We just learned it some minutes ago. Can you remember? Just pause this video and think. Alright, if you have the answer, let me now give you. Compare it with what I want to say. Filtration. Very simple. All you need to do is just to pour this thing into this, and then you have your calcium carbonate, and then the sodium chloride will pass through the filter paper, and then you have it in the beaker. Okay, so that is it. This is for calcium chloride and sodium carbonate. Now, the second one is lead nitrate and sodium carbonate. Okay, so this is a lead nitrate. I'm going to just take some, okay, and then we'll see what happens. So what happens? Still transparent, and then we'll have a, so let's see. Wow! Can you see that? Wow! Wow! That was so fast. This reaction is very fast because lead is very, very reactive. Alright? Lead and sodium are very, can you see? This is the typical, I'm seeing the precipitate inside. White, also white precipitate is formed. And the precipitate, so it is insoluble. That's why we can see it. Alright, that precipitate is lead carbonate. It's lead carbonate that is there. Sodium nitrate is soluble, it's also in here. If you want to recover it, you pass it through filtration, and then you have your different substances or different compounds you're looking for. Wow, this is wonderful. Alright, so this has brought us to the end of today's lesson. But let me just do a recap. You know, we looked at 4 different separation techniques, alright? We have the sublimation, filtration, separating funnel, and then we have precipitation. When we looked at sublimation, remember it is a process whereby when a solid is heated, it changes directly to what? A gas. Okay, beautiful. And we'll give examples: sodium chloride, your camphor in the house, air freshener, and iodine. We also saw how iodine sublimes. And then we went to look at filtration also. We saw that filtration is how to separate an insoluble substance from a solution. And we did that. Let me just, I think, wow, this is exactly what. Now look at it. This is I thought it's a slow method. Look at it. Filtration. This is our water. It's clean. And then look through the filter paper. You can see the solid substance. Yes, this is our calcium carbonate. And this is our water. So we have been able to separate calcium carbonate from water, from its solution. Very wonderful. Okay, so that's it. That's filtration. And then look at separating funnel, separating immiscible liquids, alright? And then we look at petrol and water separated, then finally precipitation. remember that a precipitate is formed during a reaction. That process is called precipitation. It's alright. I believe that you learned something interesting today. Okay, take care of yourself and enjoy the rest of your day. Bye-bye.